Okay, so I'll start presenting the screen. So all are able to see the
Yes, ma'am.
website
Yes.
www.polestar.com/circuit/circuit.js.html. You know this link, isn't it?
Yes, ma'am.
Yes, ma'am.
Everyone knows.
Okay, so in the same link, I'm trying to verify the logic gates. So as usual, I'm going to open a blank circuit. Okay, I'm going to open a blank circuit. Now I have to verify what are the gates that I'm supposed to verify. There are some 7 to 8 gates that I will be verifying for the truth table. No, so what are the various gates? Last class itself I have told enough introduction.
AND gate, OR gate.
NAND, NOR, then R and XR and XNOR.
XOR.
Okay, so all the gates we
It's
are
not.
going to verify for the truth table. Alright, for a 2 input gate. So as usual, I opened a blank circuit. All are able to see the screen that I am presenting, isn't
Yes,
it?
ma'am.
Okay, now I am going to assemble the components as usual. So I am going to draw, right, and there is a logic gate input output tool there. In that I am going to add the first gate that I want to verify, that is R gate. Okay, so R gate I am assembling, okay, like this. This is a symbolic representation for my R gate. Now I want to, this is 2 input gate and 1 output. Okay, so 0, 0, 0, 1, 1, 0, 1, 1 combinations of inputs you are going to give, and what is the output that you are going to verify. Again, I am telling you this is the R gate. So what logic operation is performed by R gate? R gate performs what logic operation? Ready-made answer should come from your side. R gate performs what logic operation?
Logic
What
Addition.
addition.
logic?
Addition.
That is
Addition.
logic
Addition.
addition. So you need to give 2 inputs. So same draw logic gates input I am giving, 2 number of inputs I have to give. So this is my input, which might be low or high. 2 inputs, so I am assembling 2 inputs here. Right. Then in the output side, I have to add one output again. So same logic gets input and output. I am choosing an add logic output. Then I am giving an output. Okay. All are able to see now? Yes
Yes,
or
ma'am.
no? Okay.
Yes,
So
ma'am.
now I will be using a wire to connect. Okay. The input is connected. 2 inputs are connected here, and output is also connected. Alright. So 4 conditions I will be satisfying. So I am just copying the same circuit, and I am pasting it the same. Alright. So 4 times I will be verifying the gate. Okay. So I am doing 4 copying. So what is the first combination of input? 0, 0. What will be the output? R gate. So 0, 0. What is the output?
Zero.
Logic addition 0.
Zero.
So
Zero, ma'am.
both the inputs are low. So low, low, 0, 0. The output is low. Okay. Second case 0, 1. So first input is low, but the second input I am making it high. Just click on it, it will change to high state. So 0, 1. So what is the input that it is displaying?
One.
High.
One.
Okay. And
One.
other combination 1, 0. So this one I am changing it to high. So 1, 0. Again, as you can see, logic addition 0 plus 1 is giving you 1 high state. Okay. Last condition is both the inputs are high. So the output is also high. Okay. So this is how you are verifying what gate? Logic addition by using what gate?
R gate.
OR gate.
See, now all are able to see it again, the screen.
Yes, ma'am.
Yes, ma'am.
So what we are verifying now? 4 conditions of the truth table that is verified in a single circuit itself. For what gate?
OR gate.
Okay. Okay, so I will go to the second one, that is AND gate. Have you understood how to verify OR gate?
Yes, ma'am.
This whole circuit combination you copy and paste it in your PDF file, okay, for OR gate. Same thing you have to repeat for the other gates also. So I am opening a new circuit again. Now I will verify AND gate. Okay. So again go to draw logic gates input and output. Now I will pick an AND gate and I will reconnect. Okay. The next step, what is the next step that I have to do? Again I will pick draw logic gates. I will choose two inputs. Okay. And outputs. Okay, and using wire I will be connecting all. Okay, and again I think there is a misconnection, bad connection is there. I connect it again. Okay. So again I will cut copy 4 times the circuit to verify the truth table. So I will control C, control V 4 times and copying. Clumsy a little bit, okay, but you copy it in a correct manner, right? All are doing the same thing in your system. Are you trying it out in your system, own system?
Yes, ma'am.
When I am verifying AND gate. So tell me somebody truth table for AND gate and what logical operation does it perform?
Ma'am, AND gate performs logical multiplication.
Logical multiplication, and tell me the 4 combinations of inputs that you will be giving.
0 0 0 1 1 0 1 1.
Okay, so 0 0 logical multiplication. So only when both the inputs are high you will be getting the output high.
Yes,
Other
ma'am.
cases it will be 0.
Low.
So first case 0 0, both the inputs are low, so the output is low. Second case, first input is 0, second input I am making it high, so still the output is low. Third case, first input high, second input is low. That means 1 0 combination, again the output is low. Fourth case, high high, that means 1 1. As you can see, okay, as you can see, the output is what?
High.
High. Okay, so again you have to copy the entire combination of 4 circuits and you have to paste. Understood what you are supposed to do for this experiment?
Yes, ma'am.
Okay, next. I'm opening another circuit, blank circuit. Now R and AND I have verified. Next gate that I will be verifying is not gate. Okay, not gate is otherwise called as inverter. Alright, so I will pick an inverter that will be my NAND gate. So this is my NOT gate, for which how many inputs and how many outputs will be there?
One input.
One input and one output. Same way I am picking input and output and I am placing and I will be connecting by wire. Okay. I'm hoping all are repeating after me. Next I will be connecting an output. Okay. And connect it by using a wire. Here two conditions only will be checking when the input is low and when the output is high. So I am copying the circuit only one more time. Okay, so two times I have copied. First, when the input is low, the output will be high. Okay, 0 means 1 because it's an inverter, not gate, it's a bubble. So input is low means output will be high and input is high means output will be low. So let me see, check what will happen if I am setting high. As you can see, the output is bubbling back or toggling to low. So this is how you will be verifying what is the name of the gate.
Not gate.
Not gate. Okay. Next, we have verified OR gate, AND gate, and NOT gate. Next, you will be verifying what gate?
And.
NOT. Okay, NOT we will verify.
Okay.
Okay, NOT. So I am adding a NOR gate. Okay, as usual, I am going to connect. Or somebody will you present NOR gate rather than me doing everything. Every time you are verifying a gate, with 4 conditions, you have to copy it. Somebody tell me what is the truth table for NOR gate. NOR. This is NOR that I am trying, so it will be inverting the R, logical addition. Again, I am copying and I am pasting it 4 times to verify the truth table. So 4 times like this you copy. Somebody tell me the truth table. When both the inputs are low, logical R means it will be logical addition. So output will be 0. 1, 1, and then 1. So if it is a NOR gate means quite the inversion, that is opposite you will be getting, that is 1, 0, 0, 0. Okay, so first two inputs are low. 0, 0 means high you are getting. Okay, 0, 1 I am keeping. So this I will be putting it high, so still low. Next, if this I am setting high, that means it is indicating 1, 0. So still the output is low. And the last case when both the inputs are high, still the output is low. Okay, so this is how I have verified. What is the gate that I have verified just now?
Or
Not.
NOR, not R.
Not.
NOR, NOR. Okay.
No.
So next, NAND gate you verify. Okay, pick NAND gate. It will be the inverter of AND gate. So AND gate is performing logical multiplication. So whatever may be the output, that will be inverted. Okay, and we will be getting the output. So as usual, I am picking 2 inputs. Connected by wire. Okay, and then you copy the circuit as usual and paste it 4 times to verify the truth table. mic open. Mute your mic.
Thumbnail is shown.
Yes.
Mute your mic.
Okay, so 4 times you copy. Tell me the truth table for NAND gate. It's logical multiplication. So when
Yes,
we
ma'am,
one
I'll do it. Ma'am,
both when we one both the inputs are high, you will be getting output high. Okay, but it NAND gate means quite the opposite. Only
low.
when both the inputs are low, you will be getting high state.
Hi.
So
Yes,
both the
ma'am.
inputs are low here, high state you are observing. Suppose if I want 0, 1, so 0 high. Again, you will be getting 0 if it is an AND gate, but high state you will be getting if it is inverted. Same you will get for the third combination also when the first inputs are high. But for the last combination when both the inputs are high, with low. You can see, isn't it? So this is how you will be verifying. What gate have you verified just now?
NAND gate.
NAND gate. Okay. So we have verified OR gate, AND gate, NOT gate, NAND gate, NOR gate. Only one more gate is there. That is XOR gate alone is there. There is no XNOR gate. So let us verify that. So add XOR gates. This is my XOR gates. Again add inputs. Connected by wire. As usual, you copy it, paste it 4 times. And I'm not copying 4 times, please go. Okay. So tell me the truth table for XOR gate. 0110 or 1001? 0110, no? Which one? XOR 0110 or 1001?
011.
So 00 means low states. 01 means high states. 10 means high states. 1 input. Change it. Okay, so you can change it and you can check. Otherwise, here itself I will change high. So you can see yourself for yourself. The truth table is 0110. Okay. So XR is thus verified. One more gate you have to verify XNOR, but the gate is not available. So how will you be possibly obtaining the output? You tell me, is there any possibility of getting XNOR gate? One easy method is there. I want to observe XNOR also, but as you can see, there is no XNOR gate. So any possibility that you can think of using any other gates? Just to add an XOR gate, okay? Whatever may be the XNOR output, that is the inverted value of this XOR gate. So I am adding a NOT gate. inverter, or not. Two logic inputs I am giving as usual. And output I am giving you. This is how you can verify XNAR. Let's see whether it works or not. I am connecting everything by wire. Okay, so let me see. So first thing is 0, 0. The output is high. That means 1, 1. 1, 0, 0, 1 I have to get. Let me see. 0, 1 I am keeping. So 0. Other way 0. Then both are high means 1. Okay. So XNAR gate is verified or not this way? Are people there or not?
Yes, ma'am. Verify.
Okay, so you understood how to verify all the gates, huh?
Yeah, ma'am.
Yes, ma'am.
This is a very easy experiment only. Okay, just you have to place 4 combinations of the same gate in a single circuit, and you have to keep the truth table combination and then check out the outputs and paste it PDF. Okay, I think for all the gates, that's all. Okay, that will complete up this experiment. Understood?
Yes, ma'am.
I think that's all for today. Any other doubts you have? See, and one more thing I wanted to tell you in this wall stat. Okay, suppose if you want to have a variable DC source, like you, if for BJT characteristics and all, you want to vary the input voltage, no? But you are keeping a fixed source and you are inputting data every time. But you can go for a variable voltage source also. There is a variable voltage source there. Add variable voltage. This is my variable voltage that you can connect it. Okay. So you can fix the values here. You can change it maximum to any value that you want. So there is a slider there. Just by varying the slider, you will be able to vary the voltage. This variable voltage you can use if you want to obtain the BJT characteristics, Zener characteristics. That way it will be easy rather than keeping a fixed voltage source and every time inputting a data. Okay, understood this component?
Yes, ma'am.
Yes, ma'am.
Any other thing that you want to know? I will wind up the class early. Only I think 3 more experiments are there. There is no much time for you to learn it out. Next experiment is very simplification of a Boolean expression, and for that you need to know Karnaugh and all. I think some of you must have studied Karnaugh in your lower class. Some of you must not have. So you should learn it out. Then only you can proceed with that experiment.
Ma'am, what Boolean equations?
But now
Ma'am, you are talking about.
I am talking about verification of a Boolean expression only. I think some of you must have studied in your lower class. Yes or no?
Yes, ma'am. Yes, ma'am.
Yes. Okay, they will give you a complicated expression. You have to use a Karnaugh map and you have to simplify that expression and implement it with their logic gate. And that logic gate implementation, you have to do it in each circuit. You have to obtain the output. Same way as I proceeded today. That is the next experiment. And before that, you need to have a demo of fluorescent lamp that I have left it out. And that I will do it. Okay, when I am free, I will load up a demo. Okay, in your ECR that you can check it out. Okay, how to give connections for a tube light arrangement. That will finish up that experiment. And 2 more transducer experiments are there. Okay, but LVDT and strain gauge, whatever is included in your syllabus, it's not there in any virtual lab. I will check anyway. Okay, but have you understood today's experiment?
Yes, ma'am.
Okay. So with this, we will wind up the class. I think that Boolean expression is there next week. Maybe we will try that. And load test and single phase transformer. How you are proceeding? What you are doing in load test single phase transformer? All of finished. I told you that you want to calculate power also for calculating efficiency and power factor. How are you doing that experiment? Single phase transformer. Have you
Which one,
finished?
ma'am?
Load test on single phase transformer.
Then we have to take 3-phase.
I am telling load test on single phase transformer and you are telling 3-phase. Have you finished that experiment load test on single phase transformer? That is my question. Have you tried it out?
No.
So you have not tried out load test on single phase transformer? None of you tried load test on single phase transformer?
No.
So how to do? Tell me. I will think of some way to determine the power. Instead of wattmeter, I will try to use a resistance, current coil and a pressure coil. So tell me what are the components that are present in a load test on transformer. You need to have an input source, I think so. That is my AC source. One terminal. So I am adding up an AC source. Two terminal.
Ma'am, you are talking about experiment 4.
I don't know the number. I think it's 6.4 only. Load test on single phase transformer. I did it on 1 week. But I told you you have to calculate power also. But there is no provision of wattmeter there. So I asked you to try the other things only. Noting down input voltage, input current, and output current. With that, we stopped. You don't remember? Do people remember or don't remember?
Yes, ma'am. Yes, ma'am.
So you
Yes,
did not
ma'am.
try it. Nobody tried that. You know how to change the turns ratio, isn't it? How will you change the turns ratio?
It is there in edit option.
Yes, so I want to change this to 230. This is 230, I will fix up.
230:6.
Yes, 230, I will fix up. 230. Output voltage 15, I want. What is the turns ratio that I have fixed the last time? Here, output side, I want 15 volt. What was the turns ratio I kept?
It was default.
0.5.
Yes, ma'am.
Then one ammeter voltmeter you have to add in both the primary side and secondary side. Trying to drag the component. Ammeter I have to add. Voltmeter I will add. Then here also voltmeter, ammeter. Then wattmeter, instead of wattmeter, I will try to give a current coil and a pressure coil. I will try what happens. If it's working out, we can also do the same thing. Otherwise, we can stop with taking input voltage, input current, and output voltage, output current alone. That is enough. I'll finish off that experiment. So what load have I given? I will try to implement the wattmeter with the one resistor. here also. Resistor, and this will act like a current coil. Okay, to parallel to the current coil, I have to add one pressure coil. So let me check out how it works out. If it is working out, you can also do the same thing. I am trying to represent a wattmeter using this combination. It's working out, we also follow the same methodology, otherwise leave it. Okay, this is my current coil, like wattmeter symbol is showing a current coil now. So I am replacing the current coil. Now I have to add a pressure coil. So I will add resistor one more time. Same here. And then an inductor I have to add. So this will act like my pressure coil. So that's why. Okay. I will connect everything. This is actually a symbolic representation of wattmeter. So I am trying to go in this way. If it is giving result, you can also do the same thing. Otherwise, let us stop with noting down input and output voltage alone. That is enough. Okay. So output side, I have to connect one load. I have asked you to connect one bulb load. That means I have a switch. So in this case, I am connecting only one lamp load. Okay. So this symbol I am using as a wattmeter. Let me see whether it is displaying power or not. Okay, so this one is representing your primary current that I am circling. This one primary voltage. This one secondary current, secondary voltage that you have to note down. Okay, let me try to stop. Okay, maximum value 115. What is the turns ratio actually? 115 divided by 230. What is the answer? 115 divided by 230. What is the answer?
0.5.
0.5 only, no? Even 0.5 only, no? Turns ratio.
0.5.
So I will. So this is my primary current. Okay. I told you this instead of seeing all the waveforms together, you can unstack all.
Yes, ma'am.
Load
What does
the
unstack means?
uh, so this waveform also I know. So I can view in scope second waveforms. So one by one the waveform will display. So the first waveform is showing you, I think, current. You keep it the cursor near the peak value and note down the voltage showing what is the current and what is the voltage, note it down. Still the secondary values also you have to note down.
Ma'am, your voice is breaking.
The secondary parameters also I will use scope. Okay. Scopes I will put that all. Okay, so four waveforms. First two are primary values, second two are secondary values. Keep wherever you are having around 150. Okay, it's milliamp showing. The secondary voltage should be around 150. Now I given correct turns ratio, that is point. Okay. And here I will note down only power only. There are three bad connections it's showing. Maybe I connected bad because of which the answer is not coming. Here only the power alone you note. Low voltage current I will take it out and only show power consumed I will save. The fifth waveform is showing the power consumed. That is 14.16 point it's showing, some watt, right? So that you can note it down, and with that you can calculate the efficiency and power factor. Okay. One by one you connect load. Here also you do the same thing. You view in scope. Okay, and stack all. The last waveform will give you secondary power. Again I will click here and I will put only power alone. Okay, I will click off show voltage, show current, and only show power consumed I will put. Okay. That's all. So this is having 2.3. Like that you can calculate power. I think I have given some bad connections or something. That's why the output is coming a different value. But you understood how to proceed with the load test and single phase transformer, na? Yes or no, ma? So this is how you have to give connection for a load test and single phase transformer. People, are you able to hear me or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so what are the things that you will be calculating for load test and single phase transformer? Connection you give it like I am showing in the screen. Okay, here the voltage should be 230, here so voltage should be 115. Accordingly you set the turns ratio here, and you have to connect ammeter, voltmeter. This will show primary current, this will show secondary current. Sorry, primary voltage. This one will be secondary current, secondary voltage. And there is no wattmeter, so I am trying to realize wattmeter by using the current coil and pressure coil in combination. Okay, this way you can try it out. Okay, roughly you take reading. It may not be accurate. And lamp loads I am giving. First you have to take no load reading. No load reading means both the switches you push it on, disconnect it, alright, and you note down here the voltage will be 230, here it will be 115, and there is no load, so no current will be drawn. It will be almost equivalent to 0 as shown here. That is no load reading. Power will also be 0 because initial reading. Then you close one load and repeat the same step. You have to note down primary current, primary voltage, primary power, secondary current, secondary voltage, secondary power. Okay, and there are some formula for calculating voltage regulation and efficiency, power factor. Efficiency is given by what formula? Efficiency, what is the formula? General formula. What is the formula for efficiency generally? I'm not asking a tough question. What is the formula for efficiency? If people are able to hear me out or not, output power by input power. Okay, so this power consumed here and divided by the power consumed in the primary side, you take the ratio and you calculate the efficiency. Power factor, what is the formula? VI cos phi divided by VI is given by power factor. So VI cos phi is the secondary side wattmeter reading. So divide the secondary side wattmeter reading by the product of voltage and current in the primary side. That will give you power factor. Okay. Understood?
Yes, ma'am.
Okay, and one more thing, voltage regulation, how will you calculate? Voltage regulation on formula I told you, no load voltage minus full load voltage divided by full load voltage. No load voltage will be 115. Okay, so 115 minus every time you add one lamp load, you take the secondary side voltage, that will be a full load value. If I close the switch, that will be the second reading, that will be the second full load value. So like that you can calculate regulation. For calculating all the parameters, you keep the cursor exactly at the peak. Okay, stop it. Okay, stop the waveform and keep the cursor exactly at the peak. Okay, exactly at the peak. This is primary voltage, that is around 230 you will get. Okay, peak, this is the primary voltage. Around the peak you see, around 230 you have to check. 227 is maximum, means you stop here. This is the primary voltage. This will be the primary current. Okay, like this. And then this will be the secondary current, like that. Keep near the peak and check. This is the secondary voltage. Should be equal to 115. Okay, accordingly you set the turns ratio. I think I did some mistake or something. Last time it came well. Now it's not showing. Maybe I did some bad connection or something because of which it's displaying. But here if you get 150. Okay. Same way. Power. Last two things is power. Okay, 60 is the primary power. And here you will be getting a secondary power. Okay. That's all. Understood how to do load test and single phase transformer?
Yes, ma'am.
Okay, so with this experiment is also completed. This is how we have to proceed with the load test and single phase transformer. Any other doubts if you are having, now is the time to ask. Rather than WhatsApping me when I am busy with loads of messages, when I am not able to answer your queries, this time you ask. Any doubt if you are having?
Ma'am, I had asked if my manual graphs were correct, ma'am.
I have not checked them and I was a little bit busy. I will be checking only when I am free totally. I am having some other work. Okay. Before I have to enter the second average, I will correct 3-4 experiments. That time only I will check. I think I have not corrected even a single process. And well, I have to do it. Okay, anyways. When I am finding free time, I will do it. Okay. Any other doubts from your side? This is the time to ask me. Tanishk, Utkarsh.
No, ma'am.
Anybody else have doubt?
No, ma'am.
Okay, so you people understood these experiments how to conduct. What will you do for verification of logic gates? Tell me the procedure. Why people are leaving? I have not told you to disperse. Dhanush and all is leaving. Only 3 o'clock. So what are the two experiments that you're supposed to finish? One is load test on single phase transformer and the other one is verification of logic gates, all the logic gates. So for each and every gate, you copy it 4 times and you verify the truth table. Alright, and you copy the entire screen and you paste it as a PDF file. That is an easy experiment. Load test on single phase transformer. First thing is without the load, you have to take all the readings. Then one by one, you have to insert the lamp load and then take the similar readings. Out of it, you have to calculate power factor, efficiency, and regulation. Even if the answers are not matching accurately, it's okay, but you try it this way. Alright?
Yes, ma'am.
Okay, ma. Let me check what answers you are getting. Okay, because reality and the simulation sometimes may differ because there is no wattmeter. I am trying to realize wattmeter function some other way. I don't know how successful it will be, but you try it this way. Okay.
Yes, ma'am.
Okay, with this all can discuss, ma'am. I am hoping all understood. Okay, I will open the deadline for these two experiments. Okay. All are free to leave.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay, ma'am.